So this is your last video for the universe, and this particular video is called Stars. I told you at the very beginning of the unit that we would look at our stars. We're going to look at characteristics, we're going to look at how they're so-called born, how they die, and what their life cycle looks like. And we're also going to look at what the electromagnetic spectrum tells us about those stars. So let's go ahead and get started. Stars are basically burning hot balls of gas, and we classify them, and when I say we, I mean astronomers, classify them by size, temperature, and brightness. And our sun is the closest star to Earth, which means it provides all of the energy necessary for a lot of the processes that happen on Earth. It's a mere 93 million miles away. It takes the light from the sun, that's radio, microwave, all the way through to gamma, about 8 minutes to get to us. That's what the distance is. So each star is classified by its size, temperature, and brightness. But we can learn a lot about the star based off of its mass. The mass of the star determines how long the star is actually going to be in existence. It makes perfect sense. If you have a large vehicle, then the large vehicle has a very large gas tank, but it's also going to use that gas up very quickly. Whereas a small vehicle has an economic gas tank. You put gas in and it can stay and go for a very long time. Stars are a lot like this. So there are 5 sizes of stars from smallest to largest. We have neutron, white dwarf, medium, giant, and supergiant. And the mass of the star is going to determine which pathway it takes and where exactly it is in its quote-unquote life cycle. So again, think about an 18-wheeler versus a Mini Cooper. Which one's going to get the better gas mileage and which one's going to have the larger gas tank? Stars are also classified by their color. The hotter stars are going to appear blue, and this is where the electromagnetic spectrum is going to come into play. Higher energy, higher frequency, smaller wavelength waves are going to be given off of stars that are typically hotter, so they're going to appear blue, whereas the cooler stars are going to appear red. We talked about how a flame, the hottest part of the flame is blue, the cooler part of the flame is red. And they're classified by 5 colors. Cooler to hotter, red, orange, yellow, white, and blue. Stars are also classified by their brightness. We can also call this magnitude or luminosity. And we have 2 types of magnitude. We have apparent and we have absolute. Apparent is how bright it appears from Earth if we look up in the sky, and absolute, if we put all of the stars the same distance away from Earth, how bright would they actually appear? So 2 astronomers, one by the name of Hertzsprung and the other by Russell, got together one day and they were looking at the stars and they were looking at these specific characteristics. And they decided to go ahead and plot the stars on an axis, on an X and a Y axis. They put temperature and color on the X axis and luminosity or magnitude or brightness on the Y axis. And they started to discover some individual patterns that the stars grouped together. So let me show you what they came up with. This is called the HR, or the Hertzsprung-Russell diagram. This is exactly what Mr. Hertzsprung and Mr. Russell put together. They started noticing that the stars that were brighter but cooler in temperature would appear to the top right of the graph, whereas the stars that were smaller but hotter and less bright were at the bottom left. Then you'll notice that there is a diagonal. These are called main sequence stars. These are medium-sized stars that as you travel from the bottom right to the top left, the temperature increases as well as the brightness increases. So wherever the star is in its life cycle, that's where it was plotted on the HR diagram, and it simply shows the relationship between temperature and brightness for the majority of our stars. Now, stars go through a life cycle, and when I say that, they don't have a mom and dad, but they have to come from something. And so stars start out as a nebula, and depending on the mass, that's going to determine which direction or which pathway it takes. So let me show you what that looks like. This is a map that you simply can follow based on the mass. So medium-sized stars are going to go on the top. Huge stars or giant stars are going to go along the middle, and really big stars are going to go down at the bottom. And you'll see that each one has an individual pathway based on what has to happen. Pause the video and sketch this out in your notebook. And that is a wrap.